Good afternoon, everyone. I am Dr. HimaBindhu. I will be teaching the robotics subject for the 6th semester mechanical engineering students. And my today's topic is about types of automations. What are the different types of automations and where they are being applicable? What are the examples of the automation that we'll be studying? And we'll be seeing about the different types of driving systems. What are the different types of driving systems and how they work, right? So firstly, coming to the automation. What do you mean by automation? What is an automation? Automation is nothing but the process which is done automatically, right? Any particular process in production or manufacturing, whatever we have, the process which is done automatically is known as automation, right? In that we have three types of automation, that is fixed automation, programmable automation, and flexible automation, right? We have three types of automations. What do we mean by fixed automation? Fixed automation is nothing but the program which is fixed. The program which is fixed, where the production of the products will be in a fixed process, that is one product design will only be done. In the fixed automation, we can design only one product's design, that is fixed. That is, we cannot go for number of different productions, number of different design productions in fixed automation. That is, for example, we have an industry where we are manufacturing some nuts and bolts, for example, right? So there we cannot go for different types of designs automatically. We cannot design different designs at one particular production batch, at one particular production series of operation. We cannot go for different designs, where at one production design series operation we can design only one production of the automated design. Clear? That is, here in this particular fixed automation system, we can have the design process, the sequence of the design process is being done in a fixed manner, where we can produce only the where the product which output which we are getting will be in only one production design, right? That is the fixed automation system. Now, the best example for the fixed automation system is automobile parts, right? The best example for the fixed automation is automobile parts. For the automobile parts, the design will be fixed and the production will be done in a fixed manner, where we get only one design production at one sequence of process. Coming to the programmable automation. Programmable automation means what? We are giving some program. We are giving some program to a system, and the production of the product is being designed according to that particular program, right? Here we can give one. Here to the machine we can give one program. We can give two. We can give three programs automatically. Where here what is happening? In the first one, it is designing, right? In the second one, it is manufacturing, and in the third one, the production output we are getting, right? So here what is happening one by one? It is first initially design of a particular nut is being done. Then the manufacturing of this particular nut is being evaluated. Then the final output of the nut we are getting in a sequence operation. Now here in this particular type of the programmable automation, this can be done for limited, for medium productions. This type of programmable automation can be done for medium production, where the batch sequence is limited, where the batch sequence is limited. Whereas coming to the flexible automation, the best example for flexible automation is flexible manufacturing system, right? The best example for flexible manufacturing system is the flexible automation is the flexible manufacturing system. So here in this, what is happening in the flexible manufacturing system? The production is flexible, right? That is, we can change. For example, this is our machine, right? Here we have some we need to design bolt. Here we need to design nut, some screws to be designed, right? So in one particular machine we are programming three different we are inputting three different programs. In one particular machine we are giving three different programs, and accordingly, flexibly, whatever is the requirement, right? Accordingly, that is, whatever is the flexible requirement is being required, the production is being done, right? The production is being in the flexible manufacturing system. For one particular production, for one particular machine, we are giving different three or four different programming operations to be done, and accordingly, depending upon the requirement, the flexible automation is being done and produces different designs in different series. In different batches, we will be getting different designs. That is known as flexible automation system, where one of the best example is the flexible manufacturing system. Yeah. So these are the three different types of automations which we are using in industries. One is the fixed automation, programmable automation, and the flexible automation. In fixed automation, what is happening? The machine takes only one fixed program, and it operates on that particular program and gives n number of products being designed. Whereas in the program automation, we are giving some input, program input to the system or to the machine, and that acts accordingly and gives us a batch series of the production of the products. Whereas in the flexible automation, we have two to three, four programs being given, and depending upon the requirement, there will be change in the batches, there will be change in the sequence, and the production of the product is being available. That is known as a flexible automation. And the example of the flexible automation is flexible manufacturing system, and the example for a fixed automation is nothing but the automobile parts. So this is about the types of automation and the reasons to implement the automation system in manufacturing. This we have already discussed in the previous class. The main reason to introduce this particular automation is to reduce the production rate of the labor, is to increase the production rate of the labor, to decrease the cost of the labor, to minimize the effect of shortage of the labor, and to obtain high quality of product. That is, when we are doing the things in automation, there will be less, we will have lesser effect of mistakes to be done. So there, what is happening, we'll have high efficient, high quality products as an output. So to obtain high quality of products, we will be using automation. A non-automatic night cost is avoided. That is, the day and night the labor need not work in the industries to complete the work. If the things are done automated, the production rate will increase, the cost decreases, as well as the time also gradually decreases. That is also one of the added advantage. And to upgrade the safety of the workers, automation has been required, because in bigger or larger industries, safety is required more. So when the work is done automated, there will be a lot of safety for the workers. Right? That is also one of the advantage. So this is about the types of automation and the advantages, why the automation has been introduced in the industries. Right. Next, coming to the need for using robotics in industry. What is the need for using robotics in industry? What is the main purpose? Right. That is, industrial robot plays a very important role in automation manufacturing to perform different kinds of applications. So what are the different kinds of application here in industrial robots we see? That is, robots can build performance capability superior to those of human beings. That is, the robots do the work which are highly equipped or highly workable than that of the human beings in terms of strength, size, speed, and accuracy. That is, humans may not lift higher loads, and they may not lift higher sized machines or any particular higher size particles, or they may not do the work as much speed as the robot do, and we may not get an accurate product design when the humans are doing, because there are some minute mistakes which can be done by any human being. So, when we are using robot to do all these operations, we will be getting a good result as good accuracy. The speed of the work will be improved. We'll be completing it in a lesser time. The size of the lifting of the particles or machines will be done with the help of the robots, right? And the strength which they are carrying may not be same as that of the human. So that is also one of the reason why robots are being needed in industries, right? And the next one is robots are better than humans to perform simple and repetitive tasks with better quality and consistency. What does this mean? We just perform simple, perform simple and repetitive tasks. That is, when the work has to be done repeatedly. What happens? We will be the time consumption will be more, because the same work to be done will consume more, will lack the time where the workers will relax, because it is the same work what they do, that is the work which we need to do, so let us relax for 5 minutes and start. But no, the robot will not do the same. So there, what is happening, the repetitive task whatever is to be done, the robots do it better than humans and perform and they give a better quality and consistent products, right? Next is robots do not have the limitations and negative attributes of human work. That is, the robots will not have any sort of negative thinking as that of the humans think, such as fatigue, need for rest and diversion of attention, etc. As I've told you, need for rest. In order to perform the task, they may delay for 5 minutes, 10 minutes, or 15 minutes, or it may even take half an hour, 1 hour. So all the time will be reduced when we're using a robot, because he doesn't need any sort of rest, or he'll not have any sort of attitude problems as that of the human. He'll not have a fatigue. He'll not have diversion in his attention. His thinking, the robot's thinking will be only one, completing the work, the task which is being given to a robot, whether it is completing or not. That is the main task, and it will be doing its work accordingly. Whereas when we consider human, they'll have a number of disturbances: mind stability, tiredness, diversion in the attention, leaves, etc. So when we're considering all this, robots are far better than the humans. So that is the need for industries. Next, coming to the fourth point, robots are used in industries to save the time compared to human, as I've told you just now. The time consumption by the humans is more compared to that of the robots, and the work which is being done by the robots will be done immediately without taking any sort of break. So the time consumption will be less compared to that of the humans when we're using in the industry. Next one is robots are in value poor working condition, right? And last one is improved working condition and reduces risk. That is, any sort of risk which a human cannot take, that also a robot can do. That is, there will be a reduction in the risk factors, and improvement in the condition, right? That is, the working condition of the robot will be more when compared to that of the human. So these are few of the needs of the robotics in industry, why and how, and in what kind these particular robots are more advantageous than that of the human, and how they can be used in industries, right? Coming to the next part, that is CAD, CAM, and robotics. What do we mean by CAD, CAM, and robotics? Yes, CAD means what? CAD, first, what do we mean by the word CAD? It is nothing but computer aided design, right? Computer aided design. What do we mean by computer aided design? Yes, it is nothing but CAD can be defined as the use of computer systems to assist in the creation, modification, analysis, or optimization of the design. Creation, modification, analysis, or optimization of the design. For example, we need to manufacture a piston, right? We need to manufacture a piston. So, in order to get this manufactured product of the piston, we first initially have to design it, right? We first need to initially design it. So after the designing is done, if there are any sort of modifications to be done before going into production, before going into the manufacturing step, here itself it will be modified, right? If any design constraints we have, it will be modified using the computer aided design. Or if any analysis is to be done, right? If we need to apply any sort of stress or strain on this particular system and we are checking the analysis. So there what is happening? Any sort of analysis also to be done will be done using CAD, or any optimization of the design, or enlarging or shortening or reducing the size of the particular piston. So whatever is to be done will be looked forward by the computer aided design. So here what we are doing, we are creating any particular design of, we are creating the design of any particular product, and we are checking for its creation, modification, analysis, and optimization of the design. So all that is being done with the help of computer aided design. Whereas coming to the CAM, computer aided manufacturing. Computer aided manufacturing means what? It is nothing but with the help of computer system, we are planning, we are managing, and we are controlling the operations of a manufacturing plant. Right? With the help of the computer, we will be planning, we can manage, and we can control the operations of a manufacturing plant through either direct or indirect computer interface with the plant's production resource. Right? That is any particular manufacturing to be done. For example, CNC machine. CAM means what? Computer aided manufacturing. Right? CAM means what? It is nothing but computer aided manufacturing. So what is happening here? Yes, here what is the best example? What is the best example? CNC. Computer numerical control. Yes or no? It is a computer numerical control. That is, here to this particular machine, we are giving some input, right? With the help of the computer, we are giving some coding to the machine. So whatever is the product to be developed, for example, let us take a threaded screw, right? Let us take a threaded screw. We need to manufacture this particular threaded screw. So here what we are doing for the CNC, we are giving some code, right? To this particular CNC machine, we are applying some program with the help of the code where the manufacturing process is being done automatically. That is, computer aided manufacturing system is being implemented here. That is, initially it will design the product. The next code is to thread the product. The next code is to give the finishing to that particular product. So whatever is the requirement to be done on that particular product, right, that will be given in the form of programming to the CNC machine with the help of the coding system, and we will be getting a final product. So that is, here what we are doing, we are planning, we are managing, and we are controlling the operation of a manufacturing plant with the help of a computer system, right? With the help of a computer system. So there again, what is happening? Time is, consumption is reduced, right? So here again, what is happening? The time consumption is reduced and the production is being increased. right? The production has been increased. Clear? So this is about the CAD and CAM of the robotics. So how and where and how it has been applicable, we have seen, right? Next, coming to the overview of the robotics. What do you mean by overview of robotics? Yes, robotics means nothing but robotics is defined, as we all know, it is defined as the science of designing and building the robotics which are suitable for real life applications, right? And in automated manufacturing and non-manufacturing environment. Right? That is, robotics is nothing but it is the science of designing and building a robot which makes the human life easier, whether it is in automated manufacturing or it is in a non-automated manufacturing environment, which makes the real life applications more easier and which makes human life happy. So that is all about robotics, where we are manufacturing a robot to make things easy nowadays. So there, what is happening? The productivity is increasing, reduces the which is reducing production life, minimizing the labor requirement. It enhances the quality of the product as discussed earlier. It minimizes the loss of man hours on account of accidents. It makes reliable and high speed production. Right? It makes reliable and high speed production when we are using robotics in our real life applications. Next, where and when these particular robots can be used. That is, the robots have been classified as programmable as well as reprogrammable robots. Right? So, where these particular robots can be used, programmable and reprogrammed robots, where can be used? It can be used in manufacturing and assembly units. Right? The robots can be used in manufacturing and assembly units such as spot and arc welding. We can use it for part assembly. We can use it for spray painting and material handling. How are we using this? For example, we have an industry, right? So there, at a time we need to do a welding, right? We have an aircraft machine where we need to weld the different parts of that particular aircraft machine. So there, the number of labors required are more, right? And the delivery need to be done as early as possible. So there, when we are using humans instead of a robo, when we are using robo instead of humans, what is happening? The work, whatever is being done at a shorter time with a high speed and high accuracy. That is, the welding process can be done as the program is being given to the particular robo about welding structure. So that way, that does it work automatically, right? That does it work automatically. So this particular type of the robots can be used in manufacturing and assembly units such as in spot welding. It can be used for placing the parts to assemble at different locations. It can be used for painting of the machines or aircrafts or any other equipments. It can be used for material handling, picking and placing the particular products from one place to the other without consuming much of the time. So this is one of the advantage of robots in manufacturing and assembly. Next, coming to the loading and unloading the features and capabilities of robots, that is intelligence, what does it have? Sensor capability. It can sense the object and it can move the object from one place to other. That is, with the help of the sensors, it will sense the object and it moves the object from one place to the other. It Intelligence, that is, intelligence means we are giving some program to the robot and it acts accordingly. The intelligence of the robot is acted according to the program being given, right? Telepresence. And next is the mechanical design, that is, depending upon the design being given, it will be acting. And the next is mobility and navigation. According to the mobility and navigation of the process, it will be acting. And the next one is the universal gripper, system integration and networking. Right. Next is the types of drive system. So, where is this drive system being used? Yes, we have three types of drive systems: hydraulic, electric, and pneumatic drive system. So, where these particular drive systems are being used and how they are used. Yes, drive systems are nothing but these particular systems are being placed at near the robot arms in order for the movement of the robot. Right, these particular drive systems are being placed to know about the movement of the robots. That is, for example, here in the hydraulic without much human efforts, right, the drive system is being used without much human efforts. We can do the work. That is, the work whatever is being done by the robot will be done more efficiently and more easily. That is, to actuate the this particular drive systems are generally used to actuate the linear joints and rotary joints. Right, the drive systems are generally used to actuate the joints, the robot joints. That is, we can see here, right? So there, here what we are using a hydraulic drive to have a movement of this particular gripper. Right, we are using a hydraulic joint here to have a new movement of the gripper linear in linear or rotational motion, in linear or rotational motion. That is, the drive systems have been initiated, is being required to place at the joints for the linear or rotary motions or rotary motion of the robot. Right. So here the hydraulic piston has a linear movement. Here we are using a hydraulic piston. In hydraulic piston, what are we using? We are using oil. Right, in hydraulic piston, what are we using? The fluid which we are using is oil. So with the help of the oil, what is happening? The movement of as the fluid is being sucked inside, this particular piston moves in the linear direction, and it operates it. For example, it picks the object from one place and places it at the other place, and as it is releasing, it moves back to its original position. As the suction is being released, it moves back to its original position. That is, with the help of the pressurized fluid, the transmission and the control power is being done. Right, here with the help of the pressurized fluid, here we are applying some amount of pressure where the movement of the piston is being done in the linear direction. That is, with the help of the pressurized fluid, the transmission and the control of the power is being taking place. Now, in this particular hydraulic drive system, hydraulic drive system is mostly applicable for heavy load robot application. Right, this hydraulic drive system is generally used for heavy load robot application system. And this particular term hydraulic refers to the transfer of the energy from pressure difference, not from the kinetic energy of the flow. That is, the hydraulic pressure system is being done with the help of the pressure difference being applied. Right, the hydraulic system is being done with the help of the pressure system of the oil being applied on the system where the movement of the arm is being done. Clear? And next, it has few features where the hydraulic system has to be taken place. That is, high force capability. It has a high force capability. That is, it can withstand up to higher force. It has high dynamic response. It has a high assisted braking torque. It has a good mechanical stiffness and high power per unit weight and volume. These are few of the features of the hydraulic drive system. And coming to the advantages and disadvantages of the hydraulic driving system are that the advantage is that it reduces the gear which is needed in the robot. That is, with the help of the gear, the movement of the robot arm will be done. So, with the help of the hydraulic drive system, it is reducing the it is reducing the gear requirement, and the functioning of the movement of the robo arm is being done with the help of the hydraulic system, with the help of where the fluid is being used as the oil, right? And it gives a high accuracy and better response with the help of the hydraulic system. The things which are being done using the hydraulic robo, it is giving a higher accurate and better response, and it is excellent for heavy duty and large robots. This particular type of the hydraulic systems are generally used for heavy duty machines, and it gives a more power than that of the electric drive. Compared to the electric drive, the hydraulic system is giving more power, and the main disadvantage is the maintenance is more. Why is the maintenance more? Because it is applicable for heavy duty robots, where the maintenance cost will be gradually increased. And since it is a heavy heavy machine robo, it is expensive, right? This particular type of the machines are generally used for very high-ended industries, where the cost of the robo is also expensive. So the maintenance is also in the same way it is expensive, and the machine to be designed is also more expensive, and it is not suitable for clean air environment. It requires more because it is in a larger. Since the design of this particular robo is very huge, it requires more floor area, right? Since the robo here is in a huge area, huge thing, it requires more area. For example, let us consider a figure here. In the hydraulic system, what is happening? We have a fuel tank, right? We have a fuel tank from which the fuel is getting sucked into the filter, where the since the fuel whatever we are using here in the fuel tank is oil, we have few dust particles being present. So in order to remove that particular dust particles, and in order to have pure oil, we are filtering that and we are sending that into the hydraulic machine. We are sending that into hydraulic pressure. So here what is happening? The oil is being getting surpassed, it is being getting compressed, and this particular compressed oil is being sent into the pressure regulator. It is being sent into the pressure regulator. So here what is happening in the pressure regulator? Whatever is the amount of the oil required, it is taking, and the leftover amount it is sending back into the fuel tank. That is, whatever is the amount required to the machine piston to run, it is taking that amount, and the excess amount what is being drawn from the hydraulic pressure is sent back to the fuel tank, right? It is being sent back to the fuel tank, and this particular pressurized oil is being sent into the piston, right? This particular pressurized fuel oil is being sent into the piston, and above that we have some weights, that is the object. So as the pressurized oil is being sent into the piston moves in the forward direction. As this pressurized oil is being sent into the piston moves in the forward direction or rotary direction, and moves the object from one place to the other place, or it will lifts the object from one place to the other place and places depending upon the requirement. So this is how the process is being done in the hydraulic driven system. Clear? Initially from the fuel tank, the fuel is being sucked into the filter, where it gets filtered without any sort of dust particles being present in the oil, and from there it is being sent into hydraulic pressure, where the oil is getting pressurized and sent into the pressure regulator, and the excess oil whatever we have is being sent back to the fuel tank, and the high pressurized oil is being sent into the piston, for at that particular time the piston moves in the forward direction, moving the objects accordingly. Yeah. So this is about the working of the hydraulic driven system, how it works and what are the required equipments. Yeah. Next, coming to the pneumatic drive. Pneumatic drive is also one of the same, whereas there instead of oil we are using air. Clear? In pneumatic system, instead of oil we are using air as one of our requirement, and the air is being sucked inside and the valves act accordingly. That is pneumatic air is used as a control power. Here in the pneumatic system, the pneumatic valve, there will be control in the flow of energy from a pressurized gas. There will be a control in the flow of energy from the pressurized gas. And whereas in the pneumatic system, the compressed air has most of the desired properties and characteristics of a gas for a pneumatic system, and it is non-poisonous and non-flammable. Air is non-poisonous because it doesn't contain any sort of chemicals, right? Here we are not having any sort of chemicals being present in the air. So when we are using the pneumatic system, it is non-poisonous and non-flammable because there are no chemicals. So this particular type of the pneumatic system are safer to use, right? Where air is acting as a system. And the advantages here are it gives a good accuracy, it has an excellent speed, that is the automation of the robo has an excellent speed. It does with a higher speed. The work whatever is being done with a higher speed. It is easy to install compared to that of the hydraulic and electric driven systems, and there is lesser leakage and higher can be tolerated because it is air. It can be highly tolerated and the leakage is also more, and it is economic than that of the hydraulic system. This is one of the important thing, right? It is more economical than that of the hydraulic system, but we have few disadvantages also. The disadvantage is that it is difficult to control, right? This particular type of robo is difficult to control, and the air need preconditioning, and the air whatever is being sucked into the system should be preconditioned, then only it will accept, or the movement of the piston will be done easily, or else the piston movement will not be done easily. And precision is less than its precision is less than that of the electric drive, and it vibrates and gives a larger noise, which is one of the main disadvantage in this particular type of the system. It gives more number of vibrations and more noise. Okay. Next, coming to the comparison of the hydraulic and pneumatic drive. So here what we are using in hydraulic drive, oil is being used as a working fluid, and here in pneumatic drive, air is used as a working medium. The hydraulic drive is costlier than that of the pneumatic drive because air is plentifully available in atmosphere, so it is easily available and is free. Whereas for the fluid here, we need to purchase the oil and then we need to add, so it is a bit costlier than that of the pneumatic drives. It is suitable for heavy load applications, and whereas the pneumatic drive is suitable for lighter load applications. And coming to the hydraulic drive, it acts at a lower speed with good speed control, whereas the pneumatic acts as a higher speed and give and it the controls and it has a difficulty in controlling the speed, right? Whereas in the hydraulic drive, it operates in silent and dirt, whereas it operates only in clean and gives a more amount of noise, which is one of the disadvantage for the pneumatic system. Coming to the electric driven system, in the electric driven system, we are using some electric control units, right? In the electric driven system, we are using some electric control units, and the movement of the robot arm is being done with the help of the electric sensor. So here, an electric driven system is defined as a form of machine which has been equipped designed to convert the electric energy into mechanical energy, which provides the electric control of the process. Right. So here in the electrical driven system, automation things are being done with the help of the electric sensors. And the features here are the electric driven offers energy transformation. There is a transfer in the energy which is not there, whereas in the hydraulic and pneumatic system. And to control the components are used to limit the amplitude. Right. And the advantage of this particular electric system is simple construction. It is used for it has a very simple construction where it doesn't have any sort of complicated design. It is very simple in construction. It acts at a clean air environment. It is very small. This particular type of the robo is small, so it requires lesser floor area. It doesn't require a higher floor area. This type of the robo is quite operational. That is for small purpose, for small industries, we can use the electric driven robots. Right. Now, for small scale industries, we can use electric driven motors, whereas for higher large scale industries, we will be using hydraulic driven system. Whereas for a medium scale industries, we will be using the pneumatic type of the driving system. Whereas we have few disadvantages, that is pure dynamic response. Its dynamic response is pure compared to that of the other, and it, as I've told you, it cannot lift a larger and heavier motors. It is costlier, and the speed and power compared to the hydraulic is less. Right, the electric driven systems have lesser speed and lesser power consumed than that of the hydraulic system. So this is all about the driving system. So in today's class, we have discussed about the types of automations. What are the different types of automations? How they have worked? What are its application? And what are the examples? After we have looked into the overview of the robots, where and when they are used, and what are the applications of the robots in the industries. And then we have come across the different types of driving systems, how they are used, and what are the advantages and disadvantages of the driving system. So, so this is all about today's class, and we'll be discussing the next further topic in the next session. Thank you. Signing off for today.
Like, share, and subscribe. Hit the bell icon for more updates.